Hello everyone. Today I received for service Nakamichi ZX-9. A little bit dusty. Looks like been stored for some time. What we see here looks to be in not very bad shape. At least everything is clean. Alright, let's power on. Both capstans running. That's good. Counter works. Reverse doesn't work. It tries to, but there is no force. Same with fast forward. And playback, it cannot pull the heads up. Alright, so it looks like being stored somewhere for a very long time. Okay, let's see. Generators. Wow, that's 400 gears, 15 kilogears, and that's source. Here, the switch. Okay, so if you see strange behavior in your ZX-7, ZX-9, try to use switch. That's better a little bit. At least we have same level. We'll try to get into record mode. Tries to. Looks like most work. So let's do service for the tape transport, and then let's see what else. What I would recommend for this guy. Levels are very significantly off. Let's see. Kilogears a little bit higher, but 400 gears, how many? 1-2 decibels lower. Okay, let me remove tape transport. See you in the next part. Okay guys, and here I'm disassembling and as soon as I removed bottom cover, the first which took my attention, this fancy bite belt. So I'm not sure who installed it. It's not original. This belt, it looks not too relaxed. I'm not sure why it cannot pull the heads. I believe roller arms are stuck. So now let me disconnect this wire and I will remove the top cover. It will require to pull up 1, 2, 3 connectors here, 4 here, 2 on the board there, 1 from the top, 2 from this board, which goes from here, and 2 goes for counter here. So quite a few, plus tape transport connectors here and here from the opposite side. All right, so moving on. It's not complex to disassemble, just way too many pieces. All right, so carefully removing zip tie and removing connectors. Interesting. In the X7 they all were white and they had labels. In the X9, this model, I believe it's later, number serial, it has different colors of connectors. Pretty interesting. Alright, so next I have to disconnect heads and 2 more connectors here. To disconnect heads, we also will cut off this zip tie. Alright, connector here. Oh, this one. This one goes into different direction. What has changed? I'm not sure. The one should go here, and I don't see. So schematic a little bit different than on the X7. So connectors goes different way as well. So how to remove this guy? Remove lower pins and then upper pins, and we have it right here. Don't forget to cut zip tie here and then install it back later to keep this guy from accidents. Alright, now on the top part. Two connectors from tape transports. A couple more zip ties. This is a rice head connector. Here is a connector from the front panel. Logic and buttons. Come on. Wow. It sits too tight. I'm not sure it was ever disconnected. Why it's so tight? Let me see if I can squeeze it a little bit. Done. Okay. Two right here. So this all goes. Yeah, I told you there is one more connector. Two from the counter. Those was easy. They've been disconnected before. Power from the direct drive motor. Alright, so we have one more connector which goes right there. Right here. Same place as the X9 or the X7. And here is a motor cable. This one. Okay. Alright. That should be everything. Let me check. Okay, now feeding the wires through the hole. You see how many connectors just from the front panel board. Here indicator and the buttons to control everything. Now pulling up the wires for the heads, gently find in position. Okay, so that's 3 heads: playback, record, and rise head. These 2 connectors right here, and we have 4 screws left to remove tape transport. So I will remove this button. So let me give you a better view. So what I need to do, I will pull the cable. Okay. Now all Nakamichi tape transports of this kind, they hold by 4 screws. 3 of them black. Don't be scared. So black, black here. Wow, this one in a good shape. Plastic is white, so it's been stored properly. And 2 here, the black one here and the white one on top. Why they did one of the clear color, like, I'm not sure. Why 3 black and 1? Maybe to connect ground with one of them. I'm not sure. But we connect into plastic, so there is no way, no reason to use it as a ground. Okay. And last thing I forget to do, and we need to do right now, desolder motor wire. So this ground wire, it sits right here. Done. Disconnect it. Now I can pull it and it's released. Now how to remove transport from here. In 600 I had to remove and pull down the sys control board with power supply. Okay, then we can pull it out. ZX-7 and ZX-9, there is tight space, lots of wires, not enough room to do it, so we have to open the door. It goes right here. Then we will have room to pull tape transports out. And rotate it through the wires right here on top, so a motor will get out, and then we can pull it like that. Okay, now you know. Okay, now let's see. Let me remove the cable wire. Let me remove this first. Sensor, it's a G coil, and there's power coils. Okay, and now it's not screwed. You see, the screw not sits properly. Now I can remove this board. out of sight, and we can use it right here to remove this part. Right, and from the front, like that. Cable wire goes smoothly, no issues, goes really easy. That's a good sign. So black one goes to the head. Okay. Someone was here, someone lubricating. Okay. So remove all lubricant. And here from the wire. That's a good sign, so lubricant is not dried up. Let's see why it doesn't work. I can use my finger to roll the gear. Yeah, you see rollers are very tough and goes with delay, so roller arms technically we can work them out. Really, they're still moving. It's a good sign. But they're tough. Let me see the head closely. Has some wear, but still in good shape, I believe. Okay, everything is in place. That's a good sign. Alright, this, I believe, belts has been replaced because I see here there is no slipping, so the only thing that pinch rollers hold all mechanism from moving smoothly, and that's where like we need to lubricate, clean it up, and see and check everything. And let's see other tire. Ooh, that's one original, fully plastified. Let me show you. That's why it was slipping. Alright, so here is the light. You might see it's glossy. Okay, now you can see it well. Here. Alright. Okay, you know the procedure. I did it many times. Now I will open it. A little bit different to remove these motors. Okay, give me a moment. I will prepare and I will show you how to do it one more time. Okay, I hope you would see fine. So first things first, pull it right here, remove this board. As you see, this one is different than the ZX-7 because it doesn't have DC motor on it, but it has coils for the direct drive motor. That's why we have so many wires connected with this connector. Alright. I just recently received another batch of idler tires for this tape transport, so it should be good. So here is the coils. Yeah, someone put new lubricant but didn't remove the old one. Okay. Not sure if it's proper position for the belt. Maybe it is. Okay, let me see. Wow, it's so flexible. Let me measure it. .95 millimeters, half length. It should be 4 inches, as I remember, but it's smaller. Oh, yeah. What we have here? We remove spacers from the front. Here we go. Okay. And this tape. Where is the main capstan? All right. Spacer. Okay. All right. Give me a moment. Okay, let's continue disassembly. So the next part will be a little bit tricky to remove this FG coil. So let me push the wire. Okay, and now let me remove this part. The spring go like piece by piece, raising it up a little bit while it will go above. Okay, like that. And now we can remove the coil. Good. And now we can split apart these two parts. It has 6 screws. This one is different, it's longer and it has a spacer. You see? This deck is in good shape, really. Even if it's dusty from outside, internally it's good, I like it. And if you remember, there is one more screw, small one, we need to remove. That's the record protection switch. Done. Now we can split it into two parts. No, we cannot, sorry. We need to remove springs. Is this sitting right here? And the last one here. Done. Now, belt, switch, and we have full access to work on it. Let's see this belt. Yeah, see, it's been sitting for quite a while in this position, and before it was sitting in this position, so I will replace it. All right, now you know the procedure. Remove reels, remove lever, lubricate everything, replace idler, clean up, lubricate, assemble. You may watch my other videos, I did it so many times, so it would not be a problem. Everything is the same here. Difference in the FG coil, this one, and the motor and board. That's it. See you soon. Here guys, that I'm installing new idler. Nice, and let's see how flexible it is. And then the old one is cracked when I was removing it. Oh, you see, it just cracks into pieces. It's hard plastic now. Okay, moving on. And here guys, I'm lubricating this brass bearing, and I will be lubricating this brass bearing here. So this mechanism should work nice and easy. Show you in a moment. All right, lubricated and assembled. And now with new rollers, it will be working smoothly. Alright, moving on. Hey guys, and here I completed work on this tape transport for Nakamichi ZX-9. While I was assembling, I removed the head, cleaned it and lubricated azimuth mechanism. I had to lubricate and work out both pinch roller arms, replace it counter belt, technically it's auto stop belts here, replace it idler, replace it, install it new belt here, nice and straight. The old one technically is not suitable for cassette decks. You may see yourself how it looks like. I would rather use it for something else. It's super stretchy, but it's not straight. So woven flutter would be terrible with this thing. All right, now everything is cleaned, lubricated. I hope everything will work smoothly. We'll assemble it tomorrow. Here I may show you how record head change azimuth, so you may see yourself. I'm pushing mechanism here on the wire with my finger, and here on the head changing azimuth. All right, so that would be it for tonight. I will continue tomorrow. See you on my next part. And here I'm back. So I assembled, connected all connectors, and this would be the first turn on. Here motor runs. That's a good sign. So now we have really good torque with new idler, and head goes up easily. Clean up is needed. So let's see. Let me get tape. Let's see how head sits. Yeah, everything looks fine. Quiet and quick. Really. All right. Let me clean up everything and let's do playback test. See you in a moment. Okay, and here I cleaned up, connected headphones. So now let's install the tape with music. Both channels work. Sounds really good. No problem at all. That's a good sign. Next, I will finalize front assembly. I cleaned up the front panel. And then I will connect my audio interface and we will start tuning. See you soon. And here guys, I replaced capacitors and the bias generator here and measuring on the rise head. And after replacement frequency was 106 kilohertz. I'm adjusted and as you may see it slowly goes up. So let's hit it for a minute or so. And I'm adjusting it right there from below, as you may see. So there is transformer and I'm screwing the ferrite inside the coil. So you see it's dropped as I moved. Okay, let me see. Okay, let's do, it's pretty sensitive. Okay, 104,938. Okay, let's see. It's slowly growing while heating. Like I believe around 2000 gears. It's pretty fine between 103 and 107. But let's give it heat a little bit. It works. It comes close to 105. Pretty stable. Slowly increases like by 1000. Okay. And you may see numbers right here. When it's stabilized, I will set the final value. So that's how you can do it. So measure right here on the rise head and see the signal and so on. Alright, see you soon. Hey guys, I just completed recapping audio pass capacitors in this deck and bias generator capacitors just for safety and audio capacitors to improve sound. I'm installed Nichicon Fine Gold and now I'm installed the speed check tape. And as I may see, it's a little bit low. It's 2,914. So let me see my small screwdriver, and here is the pot. And let's adjust it a little bit. Wrong direction. Alright, doesn't work. Okay, let me check and I see some. Okay, I technically used the wrong pot. The pot is right here, the white one. Okay, and that's 3000 gears, 3001. Pretty stable, pretty nice. Okay, let me install the next tape and let's see how it's performed. Okay guys, here I'm installing the azimuth tape and azimuth is a little bit off. So let me get screwdriver and gently adjust it. Oops, didn't get. It's right here. Oh no. Now it should be better. Let's see. Full range. And I will check the levels by the way. So on 400 gears we have minus 15, minus 16 between right and left channel. That's good. Azimuth is good. And it skips. let's say -15 level. Over the all range, see pitch will require a little bit more cleaning, and it's 12 kilohertz, 13, 14, and it keeps the levels, so very good frequency response. As I told, Hertz is very good in this deck. All right, so I use it just like one click on the azimuth screw to fix it. Next, let's see the levels. I'm afraid it's a little bit off. Here, let me switch. Yeah, it's above 1 volt, so it will be different between left-right channel. All right, to measure it, I need to connect to specific points with millivoltmeter and measure the levels. And give me a moment to do it, and let's go from there. And to adjust levels, we need to connect to these points here. So it's 25, 26, and ground between them. And as I told you, that levels are low. So you see, it shows 52 millivolts, and we need 90. And that's where we have low level on the indicator. And it's 400 gears, and we run in the source mode. All right. So let me adjust it. So technically I may do it from this side. I see the ports, so they're right there. 400 gears. And here I'm adjusting level to 90 millivolts. Okay. And we get 0 on this channel and almost 0 on this channel. Alright, so let's check the other channel. It's the second one. Yeah, and this difference we have, you see, 68 millivolts, and that's where we need to get to the balance spot. And balance spot is right here on this board. Let's see if we can balance a little bit. Probably I will connect both channels. It would be easier for me. Give me a moment to watch both needles at once. Okay, I'll connected 2 probes, and now I can watch both needles at once, and it's almost equal and almost 90 millivolts now. So let's do it equal with this spot right here. So you see, when I'm adjusting, that changes between left and right, so make them even. And now with 400 gear spot right there, it's accessible from above if you need to. Let's do 90 millivolts. Right. And we see the indicator shows +1. Okay, it's fine. We will adjust indicator a little bit later, but it's not even. And next step is run 15. Right. So 400 is 90 millivolts, and 15 it should be 9 millivolts. Okay, so I'm switching to 10, and you see this one is lower as well. So that's where I will be adjusting with the second port right here, and it should be 9 millivolts. Okay, left, right a little bit different, but that's how precise it is, okay, with this equipment. And now you see that deck has been fully screwed up. Right? I can remove my probes, but it will not do much difference. So it does actually. Let me see what I can do, what probes else I can use to see and adjust it with less distortion. See in a moment. Okay, I connected directly to the VTVM without 47 kilo ohm loads we had before, and levels are normalized. Let me see, now we have too much. Let's adjust it, it should be 9 millivolts. Oh, it's here. Now we can adjust. Okay, still shows a little bit higher, but it's even between left right now. Okay, and now let's see, 90 millivolts for 400 gears. Yeah, it's a little bit higher as well. So those 47 kilo ohm did affect really. Now good, 90. And now it shows even here and shows still higher on 15 kilohertz here. But we compare it levels, so you see it's 9 and 90 and 9. It's not 9 anymore, and it's not 90 anymore. I'm just switching back and forth on the deck with these buttons, and values a little bit different. Consider it 90. Oops, what's up? On 90. Yeah. It's more than 9 now. Really interesting. Couple times back and forth. Okay, now it shows lower. Guys, let me play with it. I have to set them right. It's really, it shouldn't be so. Oi, see you soon. Well guys, I decided to set by VTVM because I know I was verifying it up to 100 kilohertz. It was working pretty well, and on 15 kilohertz it should not affect, and like it has like 1 mega ohm input resistance, so it should be good. So you see 90 millivolts it shows even, but on 9 millivolts it shows higher. I will still check with the frequency response graph when I will be playing back and recording, just to make sure that it will be linear and would be able to compare the values from VTVM which I received on the chart. Alright, moving on, see you soon. Okay, next step, I'm using my generator to set 400 gears on the input. I set both ports to the position to have 90 millivolts on the VTVM, okay, right here, and it shows 0, so indicator is set properly and calibrated well for 400 gears. That's a good sign. All right, moving on. There are not many left to tune up. Now I can switch back to the output connectors because we verified indicator, and we can use it as a reference for Dolby level, and it would be easy. See. And just one more point to validate, when we have 90 millivolts set on Dolby level and set input levels to have it, right? And currently I'm connected to the outputs, and we have technically almost 1 volt on the output, on the maximum value. So that's another point to validation, because like, if you don't have millivolt meter, the thing you have to do is set 1 volt on the maximum output. For most Nakamichi decks it will work. It may be not ideally precise, but good enough. So it will be in range like of half decibel, and this would be pretty fine. All right. Moving on. Okay, and now when we have our levels which we set up with the generator and milliwatt meter, I switch into the tape. And oh, it just finished. Let me rewind a little bit. Let's come do experiment one more time. Alright, so that's the generator level, and it's here, and that's the tape level, and it's higher than needed. You may see it here, generator and tape, it's bigger. Alright, so what I need to do, I need to adjust these levels to bring them to the same values. Here, go one channel, and the other channel. Alright, now reference level and tape level. That's in line. Can reduce a little bit more. Like that. Okay. Generator, source, and tape. Very good. And it shows proper levels now. And we should be ideal. Alright, next part we will check playback frequency response. Give me a second. Okay, I'm here playing my reference tape. Here you may see the phase. And here we may see the levels. So it should be steady across all range. So it's 4 kilohertz, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. You see levels 11 a little bit higher, so we are pretty good. So from the head quality perspective, I have no doubts it's a perfect deck. So this will conclude our tuning for playback. So we set speed, we set levels, we verified levels on the indicator that it shows good. The next step would be to tune up recording. And to tune up recording, we already did major step. We set up the generator levels here. And the last step would be to set up indicator levels. And then we will record and verify that this records pretty well. See you in a moment. All right, now, give me a second, there is no contact. Okay, now when I tune it to 15 kilohertz generator level, we've seen that there was like inconsistency with levels, right? And now we can validate, we know that 400 Hz is good. Now we can validate that 15 kilohertz is good. I'm already checked it and it is not. And let's show me how to fix it. So I'm using output level to set measurements to 0 level, 0 decibel, you see, on the lower scale. Okay, and it's 400 Hz playing, and now we need to get 15 kilohertz, 20 decibel lower, and you see it shows bigger. And I'm switching here to 20 decibel lower, and it's definitely higher. So that's where it was affected by the wires, and I'm not sure why. Technically should not. So here I'm adjusted to level, and it's immediately on the indicator get to the proper level here. So this means that positions for all these 6 spots are set properly, and we don't need to adjust them. All right. So now again, like we have 15 kilohertz. Now I'm switching to 10 decibel, 20 decibel upper, and here is 400 Hz, and we have the same value, which is absolutely correct and absolutely proper for this deck. Now, when I validated everything here, I'm good to switch to recording. So let's set tape to the opposite side. We have EX120 and we can calibrate. Okay, azimuth shows a little bit off. We still will validate it, right? Now we have azimuth, levels. I don't see level. So tape here. It was a switch. Now we have levels, left channel, right channel, and bias. I would recommend always to make it like blinking, +1. Validating here. Now see, we adjusted bias and azimuth went away a little bit. Alright, checking up one more time. Levels. And now we can record. Alright, it's 400 Hz. And we technically have level at 400 Hz. So that's the source. That's the tape. Less than half decibel difference. It's fine. Now I will set levels to -20 decibel. So let's reduce both channels to say -20, and we will validate frequency response and azimuth. So we'll increase here. So 400 Hz, 1 kilohertz, it keeps level, 5, 6 levels there, 10 levels other, see the same levels, 15, and it's perfectly fine. It still records pretty well, 20, and it's perfectly fine, records with in azimuth and it keeps levels. 21, 22, starting to drop, 23, recording fine, 24, 25, okay, that's where you may see that this deck is perfect with pretty good parameters, and all our adjustments we did shows that we get a super linear response on the output when we recording. So technically that's all for adjustment. We just have to validate other tape types that everything works using SX 70 microseconds. Let's calibrate. Okay, it says off. As I didn't tune this deck, I would probably set levels first because they are essential for azimuth. Both bias will affect it. Now we can calibrate azimuth. Good. Levels. Good. And bias. Good. Right. And now let's record. I'm recording at -20 decibel level and it shows -20 properly. And it's 1 kilohertz, 10 kilohertz, 15 kilohertz, 19, 20 kilohertz. Jumps a little bit, so but maybe it's a tape. I'm not sure. You see how phase is jumping. but it's still 22 kilohertz. It's still recording pretty well. All right, and the last one. Let's get metal tape. Let's use this Sony. Let's adjust levels. Wow, everything was way off. Someone was recording very bad tape here. All right. Now we may adjust azimuth. Shows off. All right. Levels. Bias. And that's how we're recording. It's pretty nice. And reset. And now we're recording our -20. So 1 kilohertz, 5, 10, no change, 15, -0.5 decibel, 20, -2 decibel, but it's very used tape, 22 kilohertz. So everything appeared to be pretty fine. All parameters are in factory specs, and DEX records very good. So this would be it for tuning part. Now I will assemble it and ship back to the owner. That would be it. That's the amount of capacitors I replaced. Not too much, but all essential because sound goes over them. And after more than 40 years now, it's really good to have capacitors renewed. Okay, thank you, and we'll be awaiting you on my future projects. Bye bye. And here, guys, a little bit of bonus content. I decided to still check the wound flutter, and it's super good. It's 0.035 to 0.040 and pretty stable. Speed is stable, everything is good. Now let me change the tape and let's see the frequency response in a moment. Okay, I'm installed the type 1 tape. Okay, so now let's calibrate this tape. Azimuth good, level good, bias good. Okay. Recording and -20 decibel and 20 kilohertz. Alright, let me see frequency. Let's increase it. Okay, it's sample frequency. Now I can switch back analyzer and it will show us higher range, okay, to 26 kilohertz. So I can use up to 40 kilohertz. Okay, to 26. You see, it's type 1 tape and it does fantastic job, and it's -10 levels and it's 0 levels. Very good deck. Okay, now let's see, type 2 is the one we've been calibrating. I would not retune, and this is how it looks like. We tuned it before. You see how well the both channels correspond between each other, like almost like source. Okay, here on -10 we have a little bit drop, like 2 decibels on 16 kilohertz, and the zeros Let me see if Dolby C works. Yeah, same levels, good. Okay, and the metal tape. The one we calibrated. And it's good flat line. Really. I see how well it records on the metal tapes. So levels are really good. Okay, that would be it. Have a good day.